Hello everybody and welcome to today's lesson, the golden ratio and the search for perfection. Now, unlike some of the other videos that we've done, this one is perhaps requires you to do less maths and is more about you just engaging and listening and just exploring maths in a different situation where you might not have seen it before. Now, when I first heard about the golden ratio and first started looking into it, it blew my mind. It is amazing. And then I started spotting it in places that I never even knew were possible with maths. Seeing it in nature and seeing it when I was out on my walks and my daily walks and things, and seeing it in flowers and when it's on the face and so on. Okay, and I'm hoping that you'll be inspired by this as well a little bit. So before we start, as we normally do, press pause on this and have a go at this little start to get our brains warmed up. We would do it with PE. If we're doing any physical activity, we have to warm our brains up first. So before we start, we're just going to have a go at these 4 questions here with these digits. And an extension, if you're one of the keen beans that's working through these a bit quicker, is to have a go at making up your own question to go with these numbers. Okay, so did you know? Here's a picture of my lovely Lucy, 5 years old. Did you know that your height is the same as your arm span? So if you stretched out your arms and you went from finger to finger and then measured your height, that would be exactly the same. Did you also know that from your elbow to your wrist, and that red line there is just stretched out a little bit far, it should just be up to your wrist. So from your elbow to your wrist, it's the same as your foot length. Okay, give it a try. Take your shoe off and have a look. Okay, remember your shoe will be slightly bigger than your foot, or you could measure that bit, measure from your elbow to your wrist, and then measure your foot, and you'll find that those 2 distances there are the same. And there's lots of other examples in the body like that. We could, for example, take 4 of those measurements, and they would also be the same as your height. Okay, so that distance with 4 of those would also be the same as your height. And there's lots and lots of different measurements in your body that work like that. Now let's have a little look at this sequence here, this sequence of numbers. So we've got the values 0, 1, 1, 2, 3, 5. Now that's a special kind of sequence. And where do those numbers come from? Well, how do we generate that sequence? We take 2 numbers before and we add them up to give us the next one. So we do 1 add 1 is 2, 1 add 2 is 3, 2 add 3 is 5, and so on. So I'm going to give you 30 seconds to see how far on that sequence you can go. You can use your calculators, you don't have to do this one by hand. Off you go. Okay, hopefully you've managed to get some of them there. Here we go. Here's all of the numbers. Well, here's some of the numbers. They would go on forever, but here we go. Here's some of them. Hopefully you managed to get a couple of those. You can always pause the video and go back and have another go at doing that if you like, see whether your numbers match up. But this is a special sequence. This is called the Fibonacci sequence, or the Fibonacci numbers. And we'll come back to these numbers a bit later on. Now, what I want you to do on your calculator is I want you to press 21 divided by 13. Okay, 21 divided by 13, and see what you get. See what answer do you get. Does your answer look a bit funny? Do you get something like one of these 2 here? Now, if you get this answer at the bottom here, what you need to do is you need to press a button on your calculator that says SD, and that should then change it into a decimal. Now, for the purpose of this lesson, when you get a decimal answer, maybe just write it out 3 or 4 decimal places. Now, if you know about rounding and you know how to do rounding, you could round all of these decimals that we're going to do in a moment to 3 or 4 decimal places. If you're not too sure about decimals, or you're not sure how to do rounding, just write down the first 3 or 4 and don't worry too much about rounding, okay, because it'll be fine for the purpose of this, it's okay. But if you do know how to round, then maybe round these next ones to 3 decimal places. So what I want you to do is I want you to take your calculator and I want you to divide. We're going to take, these are numbers from our Fibonacci sequence. So we're going to take 2 numbers that are next door to each other, so 34 and 21, and we're going to divide them. We're going to divide the big one by the small ones, and the 34 divided by 21. Then we're going to do 55 divided by 34, and keep working. So just press pause on this video and then work your way through all of those partners and see what you notice about the numbers. Okay, so what you should notice when you've been doing that is that the numbers start to converge. They all start to go towards the same decimal number. And what you should have found is that while you were doing that, the numbers that they should go towards, they're tending towards, is this. 1.618. Now it's actually 1.618033988, and you can see all the way to 200 decimal places. So you've got 200 decimal places there, and this is a special number called phi. And this is the golden ratio. We are just going to use 1.618. That's what we're going to use. We're just going to use that part of it there, 1.618. Now this is a really special number, but we've just seen there with the Fibonacci numbers, when I divide the larger number by the smaller number in the pairs next to each other, I get an answer which is getting closer and closer to 1.618. But so what? Okay, I'm still not convinced that that's anything particularly special. It's just something that happens with that sequence in particular. Well, let's have a look where it exists. This is called the golden rectangle. Now that ratio of 1.618, that number 1.618, creates a rectangle which is called the perfect rectangle. And what that means is that whatever this side length is, we call it 1, we call it a 1, a unit 1, to a ratio of 1.618. So whatever size B is, side A is 1.618 times bigger. Okay, so whatever size side B is, side A is 1.618 times bigger. And this is supposed to be the most pleasing rectangle to the eye. It's supposed to be the most perfect rectangle. But again, is it just a fluke? Is it something special? Well, let's see what else we can do with this rectangle. If we were to cut a square from this rectangle, if we were to take our perfect rectangle and cut out the largest square we can, we'll call that square A, we would be left with a rectangle that would also be in perfect proportions. It would also be in a proportion of 1 to 1.618. Now let's do it again. Let's take another square, take our rectangle and find the biggest square that we possibly can from that rectangle. We'll call it B. So we've got square A and square B. And the rectangle that we're left with is again in those perfect proportions of 1 to 1.618. And if we kept doing that, so this was our square A, this was square B, and then C, and then D, and then E, and so on. If we kept doing that, and then we took our compass, and we opened our compass to that distance there, and we drew this curve. Okay, we drew this arc here of the circle, this part of the circle, the arc. And then we did the same. We opened our compass to this distance here, and we drew this arc, and we kept doing it. We create this beautiful spiral. So we've taken our perfect rectangle, we've split it into squares, and each time we were left with another perfect rectangle in the same proportions, and we can draw this spiral. And Leonardo of Pisa, who was known as Fibonacci, introduced this sequence, but I can't quite see yet how my sequence of numbers fits with these squares. I can't see what the connection is. Well, if I put this picture on up here, maybe now I can see. So I've got a square, 1 by 1, 1 by 1. And then if I draw a square above it, it needs to be 2 by 2. And then the next square will be 3 by 3. Then 5 by 5 and 8 by 8. Where have I seen those numbers before? 1, 1, 2, 3, 5, 8. So I can fit the Fibonacci numbers, the Fibonacci sequence fits within my golden rectangle, my perfect rectangle. But we can see examples of this spiral, of this Fibonacci sort of spiral all through nature. If we were to count pine cones and spirals in pine cones, in shells, in sunflower seeds, and in this plant here, we've got this beautiful spiral that works its way around. So lots and lots of examples there. But there's more than that, there's even more. And this is the bit that really started to blow my mind, is that if we count the petals on flowers, this flower here on the left-hand side on your screen has got 5 petals, then the next one has 8, and the next one has 21. Where are those numbers? 5, 8, 21. Maybe you could go away and have a look in your garden and pick a daisy, or just have a look at a flower next time you're out on your walk and see how many petals are there. Are the number of petals in the Fibonacci sequence? Pretty much that the majority of them will be. There's always an exception, but the majority of flowers have the petals in the Fibonacci sequence. Obviously, if a petal's fallen off, then we wouldn't know. If we were to take the inside of a flower, if you look at that bit in the middle of the flower, and sunflowers are a great one for doing this, and sort of map out, you sort of see where those yellow lines are, the spiral of the curves of as they're coming out, and we counted them. With this one here, there are 34 going one way, and there are 21 going the other way. Again, 2 of the numbers in the Fibonacci sequence. We can see that spiral in weather patterns. We can see it in space with nebulas and galaxies and so on. And you know, it exists in space, it exists in architecture because it is the most pleasing and it is the most aesthetically pleasing to the eye. We can see it in architecture as well. Leonardo da Vinci, he was a huge fan of the golden ratio and used it in a lot of his art. We can see there, this painting here is Mona Lisa. And lots of people, it has been disputed, but a lot of people believe that Leonardo da Vinci used the golden ratio and the golden rectangles to create his picture of Mona Lisa. And the same with his painting of the Last Supper, where he put people and where people are in a composition where they actually are. And it even has been said that Donald Trump himself is the golden ratio, that we can map that golden spiral against Donald Trump's ear and his hair. Not quite sure what that says about Donald Trump, whether he's the most aesthetically pleasing, but there you go. But we can also see it in pictures like on the Eiffel Tower, on the shape of the ear, on spirals within shells, so many different ways. Now, the Eiffel Tower is obviously a man-made structure, but it was created with that golden ratio in mind, with having the bottom parts with a ratio of 1 to 1.618 times bigger on the top. What about your teeth? Have you ever wondered why your two front teeth are bigger than the rest? Obviously, there's a sort of a biological reason for it in terms of how we chew and how we eat. But there's just something about that. Why still would we then have teeth that have got this perfect rectangle around the front too? And other teeth do it as well. We can work our way back and see that golden rectangle on other teeth as well. It even exists in our DNA structure. Now, I'm afraid I don't know the technical term for this DNA structure, how we would describe this, but it is still with that sort of ratio of 1 across to 1.618 up. Now, the face and the body are full of examples of the golden ratio. And people, when they are taking photographs and they are sort of manipulating them afterwards, because very few photographs we see have not had some form of manipulation on them, when they're being manipulated by the people behind the screen, what they do is they move things around and squidge eyes in or pull things out, stretch things a little bit, so that things are in perfect proportion with 1.1 to 1.618. And we're going to have a look at in a moment, doing some measurements on your body to try and find those golden ratios. But it is worth knowing that often when we see a picture that we think our eyes automatically drawn to it, or we think it is pleasing, it is often because it is being designed so that it is in those proportions of 1 to 1.618. So now here we go. Here's our task, and you don't have to do all of these measurements. You can pause this video now and you can take this at your own pace. If you're feeling confident, you could work through all of these calculations and then have a go at an extension, which involves your hands and looking at your knuckles and maybe doing some measurements around your knuckles. Okay, so take these measurements. You might want to get your parents to help you. When I was doing this earlier on today, we had people saying their parents were definitely not perfect. The children were more perfect than the parents. Children will be slightly different because you're not yet fully grown, so your proportions won't necessarily yet be quite there. But have a go at these, press pause on the video and have a go at these different calculations and see how close you are to our golden ratio. Remember, we're wanting to be as close as possible to 1.618. That's the number that we want to be as close to as possible. And the closer you are to that, the more perfect you are. And obviously everyone thinks you're perfect anyway, but it is worth just having a little look and seeing what that would be. So press pause and then press play when you're ready to move on. Your whole body is the symphony of the golden ratio. Now, I heard that quote when I was looking at this, and I just thought that was fantastic. Your whole body is a symphony of the golden ratio. You are full of the golden ratio. So a bit of homework for you is to go into your garden or look online and find some more examples of the Fibonacci numbers in nature or on your body, or do some more measurements and see what you can find. We've had a play around with today, doing things around your arm and your leg and different sort of parts of your body and seeing whether different parts are in that perfect ratio or not. Thank you very much for joining me, and I hope you will join me for some more of my lessons at a later date. Bye.